Hello everyone, a good day. I am Professor Aravindakumar from Mahatma Gandhi University, India. Basically, I am an environmental chemist. Today, I am going to talk to you something about the environmental contaminants, generally known as contaminants of emerging concern, how this acts in the environment and how do we detect all these chemicals. Now, if you look at this slide, you can see I have written two names, emerging contaminants or contaminants of emerging concern. These are basically compounds which are now not included in the general water quality parameters. So, mainly because we have no idea about the toxicity and how it acts in our human body, etc., etc. That is why this is called contaminants of emerging concern. Now, you can see that 1960s, 70s and 80s, we have the emergence of the new class of compounds called organochlorines, then organophosphates. Initially, organochlorines were identified as dangerous. Then later people realized that people introduced organophosphate. But again later now we know that they are also dangerous to human. Then in 1990, around that period, there's a new class of compounds came up as pollutants. Estrogens in sewage effluents as a cause of feminization of fish. That was a very important report, which means that these kinds of compounds, estrogens, hormones, pharmaceuticals, these are also dangerous to human. Then in 2004, there was another report which appeared in Nature, the journal Nature, that diclofenac residues as the cause of vulture population decline in Pakistan. Again, this is a very landmark report appeared in Nature, which really brought into the limelight the deleterious effect of these kinds of antibiotics and pharmaceuticals. So, to be precise, people have identified a series of compounds and they have classified these as contaminants of emerging concern. They are pharmaceuticals, personal care products, surfactants, perfluorinated compounds, flame retardants, UV filters, industrial additives and agents, gasoline and their transformation product. The transformation product of all these compounds, they are also deleterious. Then microplastic, nanomaterial, these are all classified as contaminants of emerging concern. There are various ways by which these kind of pharmaceuticals are in the environment. It's very the situation is really complex. You can see that pharmaceutical industry push lot of waste into the environment. Then hospital waste is another concern. Then from household we also throw this medicine. Then livestock, that is also very important area or place where people use lot of antibiotics and pharmaceuticals. So ultimately these are all coming to the environment. Then you can also see that there are a lot of ways by which these pharmaceuticals get transformed. For example, abiotic transformation, oxidation, adsorption, then photolysis, natural photolysis, due to sunlight it gets transformed and so on and so forth. So cleaning is an extremely difficult process. For example, water purification is difficult. Then also we have to see, unless we come to know the environmental fate of these compounds, it is very difficult to design any technology for the purification. Now, if you look at this slide, we have classified again some of the reports from global report, the reports from Asian countries, report from India and Kazakhstan and so forth. So in all these cases, initially there are a lot of reports from developed countries like UK, USA and all. From Asian countries, the reports are relatively less because these are all expensive research. But now we have a lot of information coming out from Asian countries as well. Now, we have also, I myself have published one article, particularly a review article in Chemosphere, where we have classified these type of compounds in Indian environment matrix. Now, why are we concerned? You know, there is an important process called antibiotic resistance. So, when this kind of antibiotics comes to the water bodies, this goes to fish, and when it goes to fish, ultimately it comes to human. So, when antibiotics comes to human on a regular basis, it develops a kind of antibiotic resistance in human. This is very dangerous. That is the reason why we are all concerned. Even World Health Organization gave a kind of warning that this kind of, this should be curbed in the environment. So, in order to do that, we have to determine how much percentage of these antibiotics and pharmaceuticals are present in water bodies, soils, in the air and so on. So, we have a lot of research work in our laboratory to really find out, determine the presence of these kind of compounds in drinking water, in water bodies, then in sea and oceans. Also, we have programs in Arctic and Antarctic region. So, we have published a series of papers. If you are interested, you can see some of this, refer some of these papers. Now, to determine these compounds, we need very expensive instruments, equipment, which is called mass spectrometry. This kind of determination requires combination of different instruments. For example, in this case, we are combining ultra performance liquid chromatography with a high accuracy mass spectrometry, and there are a lot of sensitive instruments which are called hybrid instruments. For example, LC hybrid MS. Then also we can use MSMS, which is called tandem mass spectrometry. Then time of flight machines. Time of flight machine is actually high resolution mass spectrometry and so on. And now in mass spectrometry, there are two kinds of analysis. One is target analysis, which is generally very easy and where you have standards available. Then also non-target analysis, and most of the analysis for this kind of pharmaceutical waste are done by non-target analysis. These are a couple of machines, mass spectrometric machines, by which we analyzed these type of compounds. Then before analysis, we have a workup procedure. For example, if it is soil, we use Ketch's mechanism. If it is liquid, we use solid phase extraction methodology. And this is one machine, that is time of flight machine, by which you analyze these compounds. One example I can show you, that this is a river, a long river from South India, which is called Periyar River, where we have collected the water. We have done the mass spectrometric analysis. In the picture, you can see various peaks. These peaks corresponds to different compounds. These are some of the compounds, identified compounds I have given in the table. You can see the different measurements, like accuracy factor, etc., etc. Then we have also identified, quantified these compounds in the water medium. And also we have identified some of the compounds in the Arctic region. We have a program with Indian Arctic Expedition, where this is a site in Arctic region. We have collected the water from sea, water as well as sediment. Then you can see the result. There we have found some of the compounds like bisphenol S in Arctic region, then surfactants in Arctic region. These are all with the mass spectrometer. So, the main reason for in Arctic region is mainly because of the human activities as well as the sea current. So, thank you very much, and I thank this South Kazakhstan University for giving me an opportunities, and I hope all the best for the university, and thank you very much.